Okay, welcome back. Today we want to look at limit comparison tests. This is the second half of section 10.4. The first half was the direct comparison, and you can do a lot of problems with direct comparison. The problem with it is sometimes getting the inequalities to go the direction you want them to go is quite tricky. The limit comparison test gets around that, but it's not quite as intuitive as the direct comparison. So let's first of all state what the test is. First of all, as with direct comparison, we're dealing with positive sequences and the series associated with them. So we want to look at the sums of the a sub n's and the sums of the b sub n's where all the terms are positive. We're also going to assume that the ratio of the two, so a sub n over b sub n, goes to some limit L. Since they're both positive, obviously L can't be a negative number, but it could be 0, it could be infinity, or any regular finite number in between. So we're going to handle those three cases separately. So the first case, when L is some finite number, so it's not 0, it's not infinite, in that case, it's sort of the ideal case. It says, well, if the sum of the a sub n's converge, well then if and only if the sum of the b sub n's converge. So whatever they do together. So if one converges, the other converges. If one diverges, the other diverges. So whatever they do, it's the same as each other. And most of the time, this is what you're going to be using this particular theorem for. However, there are the two cases here where our limit could be 0 or it could be infinity, in which case we do have to handle those as separate cases. Well, if L is infinity, well, that means for the limit to be infinity, the numerator has to be getting a whole lot bigger than the denominator because the ratio has to go up to infinity. So that tells me, well, that if the sum of the bigger things, the sum of the a sub n's converges, then the sum of the b sub n's converge. Notice if the sum of the a sub n's diverged, it tells you nothing. Okay, so it's not an if and only if statement, it's only a one-way statement here. Similarly, if it's 0, which tells me the numerator is a whole lot smaller, then if the sum of the numerator diverges, then so does the sum of the denominator. Okay, so those are the three cases in this one. Again, this first one is the one you're going to be using most frequently. Let's do a couple examples of this, though. Okay, so we want to look at, and let me flip this over here so we don't have to look at all the writing. So does the sum 1 over n squared minus n plus 1 converge? Now, this would be a tough one to do by direct comparison because you have both a minus and a plus in the denominator. That's going to make messing around with the inequalities quite challenging. Probably could be done, but it's going to be tough. So I'd really rather not do a direct comparison. However, in terms of what to compare it to, I usually look at the leading term. So the 1 over the n squared is probably what I want to compare to. So we're going to take my b sub n to be the thing I'm given, and my a sub n to be 1 over n squared. And notice if I sum a sub n's from 1 to infinity, it's going to converge because it's a p-series where the p is 2. So we take the limit of a sub n over b sub n, do a little algebra, invert and multiply, you get n squared minus n plus 1 over n squared. And when you take that limit, it goes to 1. Okay, that means since we know that the sum of 1 over n squared converges, that's a p-series, so we already had that from our integral test section, then we know that this other series 1 over n squared minus n plus 1 also must converge. Okay, let's take another example here. Well, let's take 1 over ln of n. Now this one we're starting at 3 just so we avoid any negative terms. But again, where we start the series is really not what's important here. Okay, well, I can't think of anything really nice. And that's the problem with the special cases in this one. However, one series I know diverges is the sum of 1 over n. Okay, so that's always a good comparison to remember. So remember that the sum, n equals 1 to infinity of 1 over n, diverges, because a p-series only converges if the power in the denominator is greater than 1, not if it's equal to 1. Okay, so that's what I'm going to take my a sub n to be. We take the ratio of the two, and again, invert and multiply, you get log of n over n. Use L'Hopital's rule, and you get the limit as n approaches infinity of 1 over n over 1, and that goes to 0. So in terms of our cases, we are back in this case where the limit is 0. The sum of the a sub n's diverge, so that tells me that the sum of the b sub n's also diverges. Notice that these extra two cases tend to be the ones that are a little tougher to apply. And so we'll use them sparingly, but this first one is where it really shines for this. So now we have a number of tests. We have the integral test, we have direct comparison, we have limit comparison, we have geometric series, we have p-series, we have a whole lot of these things. So we're going to be taking our test for test number 3 over sections 8.8 and then 10.1 through 10.4. So we're finishing that up. I will be posting both review tests and a couple of videos on how to decide what test to use when. So if I'm going to do comparison, what do I use for a comparison? When do I use the nth term test? When do I use the geometric series? How do I look at a problem and decide which of these things to use? Looking ahead, just to let you know, we're probably going to have you take the test during the week after Easter. I'm going to be pretty flexible on which day, so I'm going to allow each student to choose which day of the week they want to take it on. And then you'll email me with what day works for you. I will email you the test the night before, and then you'll have to submit it through Blackboard the next day. So hopefully that flexibility works with people. I know things are crazy now, so I want to be sensitive to scheduling issues and so on. So hopefully this will work. So again, I'll be doing it the week after Easter, and then we'll be continuing on with regular materials also after Easter. But look for the review test and some videos on strategies to come out tomorrow. So hope all is well, and we'll hopefully have a good test on this one.